Hello again. All right, we are continuing with the trig ratios. So today we are going to talk about the other two trigonometric ratios, namely sine and cosine ratios. All right, quick review. Tangent ratio was the length of the opposite side. So if I am looking at the triangle ABC with the C is the angle that I'm looking at, the opposite side to angle C is the length AB, so that length, whatever that is, and adjacent side is the BC, which is beside that. Okay, so we already knew that. The cosine and sine, they follow the same setup. Notice that I included the hypotenuse, and that is basically how you would know that's a hypotenuse. The longest side is always the opposite side of the right angle triangle. The right angle in a triangle, right? The length or the side that is opposite to the right angle, that's your hypotenuse. All right, first, sine, we call it sin, as in sin, but it is sine. So sine of angle C is actually now the opposite side, the length of the opposite side divided by the length of the hypotenuse side. Okay, that is the sine ratio for that angle. That means that when you divide the opposite side by the hypotenuse side, you're going to get a number. That number represents the ratio. That number represents the sine of that angle, and this C is an angle we're talking about. Okay, so remember, these we call it C, but it's actually angle C, and that's because it's capital letter. That's implied that is an angle. All right, so let's do a couple of examples and then we come right back and continue with the cosine. All right, look at this example here. I gave you this triangle ABC, but remember that now the vertices are different now. They're not the same as ABC up here, so I changed it on purpose. We want to know the sine of angle A. So in here, this is what we want. We already gave you this angle. So what is the sine of angle A? All right, first thing first, we need to label. What is the opposite? We need the opposite. Remember, we need opposite, we need hypotenuse in here. So what is the opposite? Oh, that's so the opposite angle A is 3. So that's the opposite, OPP, and always label that just like that so that you can see it. And then the hypotenuse is always the hypotenuse, the longest side, the side opposite to the 90-degree angle. So that is your hypotenuse, HYP. All right, so the ratio will be 3/5. Simple as that. Okay, now that we are at it, can we do tangent just as a practice? What is tangent of angle A? Tangent of angle A, remember, 4 is the adjacent side. Great. So what is the tangent? Opposite over adjacent, which is right up here, right? So don't forget that. That's opposite over adjacent for tangent. Excellent. So let's write that down. So that would be 3 divided by 4, or 3/4. That is the ratio for tangent. Great. The next ratio is cosine, and cosine we write it as COS, cos of angle C. Okay, and in this case, for any triangle, cosine now is adjacent side, so the length of the adjacent side divided by the hypotenuse side. Okay, the length of adjacent side divided by the length of the hypotenuse side. All right, and that ratio always applies. So if you look at the same triangle, which is right here as an example, so let me move that around. This is the example right here. Okay, so we're using the same example here. What is cos of angle A? All right, we already have everything that we need. We already labeled the triangle. We know the sides. We know one of the angles that we're looking at, angle A. What is the cosine? We have to go through, and that is called adjacent over hypotenuse. And adjacent over hypotenuse is, let's write it up. Adjacent is 4 and hypotenuse 5. Okay, so cos of angle A will have 4/5. That's a number, it's a fraction, that's a ratio. And notice that the sides are related to each other based on that angle. So cos of angle A will give you the ratio between the two sides, either cosine or tangent or sine, and these are all basically ratios, different ratios that you can come up with depending on what trigonometric ratio you're using. All right, simple as that. That is it. You can use a calculator and find out the decimal expansion of each of these, but you don't really need to. Just leave it as a fraction. But if you do need to, just go ahead and punch that in. That should not be very hard. Okay. I do need to review one concept from previous math classes. That's called Pythagorean Theorem, because you need that later on in this unit to basically solve a triangle, everything about a triangle. So Pythagorean Theorem, remember, it has to do with the relationship between the sides of that right angle triangle and its hypotenuse. And the way it is that the hypotenuse is squared equals to the sum of the two sides squares. Okay, so square of b squared, b is the squared, a is the squared, you add them up. So when you sum of the two other sides squared, you'll get the Pythagorean theorem, and that still holds. Remember that C is the hypotenuse. You can rewrite this equation for any other sides as long as you are doing the math properly. And if you go ahead and rewrite these in terms of B or C and D, remember, if you are solving for another side, you have to always subtract the hypotenuse square, one of the other sides from the hypotenuse squared. Okay, so that would be one kind or one set of equation. The next one, if you want to use, will be the same thing, but in this case would be hypotenuse squared minus b squared. So all of these are basically different variation of Pythagorean theorem. So let's do an example. Suppose A is 3, B is 4 units long. We want to know what the hypotenuse is. Okay, so C squared equals a squared plus b squared. It doesn't matter which one you start with. So let's start with b squared. Fine. 4 squared plus 3 squared. So c squared equal to 16 plus 9. C squared is equal to 25. Remember, you have to do the square first. And then to undo the power of 2, you have to take the square root of both sides. And that would be 5. So don't forget, you have to take the square root of both sides. And that would be 5 in this case. All right, so that's why the hypotenuse is 5. Now you may say, why is it not minus 5? Well, yes, theoretically you could say that this could have that, but here's the thing: we are using the positive root of that, not the negative, because hypotenuse cannot be negative. So C is equal to 5.